Now any problem on this part? It's confusing, I think. So now let's move on to another topic. Signal analysis and digital signal processing, just a very brief introduction. And we can find the correlation functions of one signal or two signals, either by analytical method or by numerical method. When we have measured a set of data for the signals, then we can solve the problem using Matlab, either by analytical or by numerical method. And also we can consider how can we solve faster Fourier transform or inverse Fourier transform problems. And then I will introduce something about filtering and filter design. In mathematics, we know that if a function if a signal function xt is given, then the autocorrelation of the function is defined like this. So this is the mathematical form. And the cross correlation function of two functions x and y is defined like this. And from the formulas, it can be seen that this one will, in mathematical term, will ask you to solve integration problems and limit problems. And this one, and this kind of problem can easily be solved with Matlab symbolic toolbox. So for this kind of problems, we can find the autocorrelation function for a certain given function by the use of symbolic toolbox functions and the definition of the autocorrelation function. Suppose a function xt is given by this, where there are several unknown variables a1, theta 1, omega 1, a2, omega 2, theta 1, theta 2, and also the variable t. So we have to declare these variables as symbolic variables, like this. Apart from these variables, if we check back to the definition, we see that we have an extra argument here, tau, and also the variable t here. So we have to declare tau and t as symbolic variables as well. So for this example, we have to declare these variables as symbolic variables. And then we can express the original function x. The original function x for x of time t. So how can we find from the definition the function x of t plus tau? How can we find this one? So what's the difference between these two? The solution to this one is quite simple. We can substitute the variable t from the original x function by t plus tau. We can call the subscript one x t plus tau. So this is the Matlab command that we can use. So if we declare the x, then we can easily find this term by using substitution. And the original problem can be solved like this. We can find the x, we can define the x, and then find the xt plus tau like this. And then we take the limit from 0 to capital T and divide the result by t. And by definition, we take the limitations for t when t tends to infinity, and finally we should get the result. So the autocorrelation function of a given function can be obtained easily by a theoretical method. And by direct integration, we should get the result like there is a problem because I called the number theory before. So how come? How to? Not sure. But in this way, actually, you can find the results. Maybe something wrong with the memory. I think if I restart Matlab again, I think we should get a result like this.
I have a question. What is the purpose of the correlation analysis? Is to change, to represent the...
I think somewhere I used... Sorry, the program of this command, I think.
No, I mean the correlation analysis. What is the
application?
The application.
Application means that if you have a signal like this, and if you shape it by tau, then what is the relationship between the two? Is it still similar or something like that? So normally the correlation, autocorrelation, if the two are independent, then the correlation is a result like this. In other places, the result is zero, so which means that they are not correlated. So mainly analyze, I think, the similarity between the signal when you shift it. Does it have enough relationship with the original? I think this is the way. So the correlation function is a function of tau. And if you are using theoretical method, you can find the autocorrelation and cross-correlation of two functions using direct command in symbolic toolbox. You can find the theoretical results. And if you have two sets of data or one set of data, then you can also perform a correlation analysis. For instance, you can use this kind of formulas to find the cross-correlation analysis or autocorrelation analysis. Also, you can use a Matlab command quite sure this one is used to find the correlation coefficients. You can use this kind of command to find the correlation coefficients. And suppose you have two functions, you want to find the similarity between the two functions. Then you can generate a set of data like this, and then you can use correlation coefficient command to solve the problem. So this one is the correlation matrix. So what about the? Oh, here are the correlation discretized form of correlation functions. These are different. So the function we have to use is XCOOR. And this one for autocorrelation, because we have X here. And this one we have cross correlation between the two variables, two sets of data. And the previous one, I just defined the correlation matrix of the two signals. This one is the cross-correlation function and autocorrelation function. And I think we have a bit better zoomed this part. This is standard way to describe the correlation function. And this one is obtained by Matlab command stand.